just want to do two last topics just to close out the unit. They're probably not going to be an exam, but they are in the curriculum. The first thing I want to talk about is just um, solving equations with multiple angle. So, for example, like sine of x equals a half. Now, you might say, can I use the double angle formula? It doesn't really work out. But if you think about it, you have the two solutions. You know that sine of 2x, we know there's two cycles over 0 to 2 pi or 360. So you know it's like 1, 2, and you know that if it's half, you know that there's 4 solutions. The question is, how do we algebraically find it? Well, first of all, you could always put it in your GDC and find the intersection points. That's no big deal. How do we solve it? Well, here's my technique. When you see the 2, you have 2 cycles, okay? But we're going to rewrite this as sine of b equals a half. Okay? Now, we know that there's 2 solutions. We know from setting sine, there's b equals 30, and b equals 150. Okay. Now, I said that there's 2 cycles. So what you're going to do is you're going to add 360. So you're going to do 30 plus 360 and 150 plus 360. So we have b is equal to 30, 150, 490, and 510. But we're not looking for b. We're looking for 2x. So we're going to divide everything by 2. And we get our 4 solutions. We get x equals 15, x equals 75, x equals 245, and x equals what? 245, and it's 250. Sorry, let's see. 2 goes into 2 times, carry the 1, 5, carry the 1, 255. So this is our 4 solutions, and this is a technique. Let's try another one, and then we'll move on. How about we do the cosine of 4x? The cosine of 4x equals, let's do a half also. So once again, this might seem tedious. Once again, you could always just put this in the graphing calculator. 1, 2, 3, 4, and you know we're looking for a half. So there's 8 solutions here, but once again, if we just take it slow, so you say the cosine of b equals a half, we know it's 60, right? What's the first? We know it's positive in the first and the fourth, so we know that b equals 60, and we know that it equals 300. Now, I said there were 4 cycles, so we're going to have to go around, and then we're going to divide by 4. That's how I do. So 60 plus 360, 60 plus 720, and 60 plus 1080. And then same thing here, 300 plus 360, 300 plus 720, and 300 plus 1080. So we have, and so what we could do is, yes, we have all these, and we can just divide by 4. So 60 divided by 4, so instead of b, we have 4x. So we have x is equal to 60 over 4, 300 over 4, we have 420 over 4, we have 660 over 4, we have 780 over 4, we have 1020 over 4, we have, 1140 over 4, and last we have 1380 over 4, and you get your answers. They're probably not going to ask this, but maybe you might see it. What is this? This is 15. This is 75. This is 105. This is, what do we have here? 1, 6, 5. What do we have here? We have 1, 9, 5. What's going on here? We have 2, 5, 5. We have here, we have, let's see, 2, 8, 5. And last we have, let's see, this is 3, 2, 4 goes in this, let's see, 4, 13, 80. So we have 3, 1, 8, 4, 2, so 345. And it's interesting because you actually see that we're going from 0 to 360. It actually contains it. So that's a little tedious, and once again, you can always put it in the graphic calculator. That's probably where it's going to show up. But this is a technique. Okay, next. Last thing, I'm just asking you 1 or 2 questions on the sheet that I handed out. The next thing has to do with identities. Now, in the class, we came up with a couple of identities already. We know that, and once again, this part will not show up. But I just want to show it to you, because this is the last little unit. Okay. First of all, an identity is an equation that's true for all values. Okay, and we know that tangent of theta is equal to sine theta over cosine theta. We also know that another identity we came up with, sorry I'm tilted, let me fix that. There we go. We know that sine squared theta plus cosine squared theta equals 1. These are the 2 identities we have, but there are other identities. What the other identities are called the reciprocals. And it's not part of the SL program, it is HL, but let me show you. So if you recall SOHCAHTOA, right? SOHCAHTOA, and we said that sine was opposite over hypotenuse. Well, you know what, you might say, Mr. Adler, can I take the ratio of the hypotenuse over the opposite? And the answer is, yeah, that is 1 over sine, and that has a name called cosecant. And we denote it with CSC theta, cosecant. Same thing with cosine. We know that cosine is adjacent over hypotenuse. You say, hey, can I take the ratio of the hypotenuse over the adjacent? Yeah, you can do that, which is 1 over cosine. We have a special name for that also. It's called the secant. And that is SEC theta. You say, well, let's do it with the last one, Mr. Adler. Opposite over adjacent. I want to take the ratio of the adjacent over the opposite. That's 1 over tangent. That's also cosine over theta, cosine theta over sine theta, and that's known as the cotangent of theta. These are just terms in trigonometry. Maybe you see them in another class. I just want to make sure that you kind of saw it, and in the future when someone asks, you're like, no, I did that. You don't need it for your IB exam, but just to see it. Now, how does it apply to this? Well, if I take sine squared plus cosine squared equals 1 and divide everything by cosine squared, I get another interesting identity. Sine over cosine is tangent, so sine squared over cosine squared is tangent squared. Cosine over cosine equals 1, and 1 over cosine, well, that's secant. Do you need to know the application? No. Are you going to be asked? No. I just want you to know this. Last thing, if I take secant, sine plus cosine plus equals 1, and divide everything by sine squared, I get another identity which you don't need to know, and it's not even on your formula book. So what's going on here? Sine over sine is 1. cosine over sine, that's cotangent. So this is cotangent squared, and this is equal to cosecant squared. Once again, these are just more identities. Now, there's fun exercise you can do to practice, and that's just simplifying expressions. And so I give you a sheet. So you'll do some problems. Here's one or two problems. The idea is turn everything into sine and cosine and see if you can simplify. So, for example, if I ask you to simplify secant theta times cotangent theta, you would say, okay, I know that secant theta is 1 over sine theta. Oh, sorry, what is secant? I apologize. It's 1 over cosine. Apologies. And I know the cotangent is, where's cotangent? It's cosine over sine. And you go, okay, I can cancel these out. This is 1 over sine. This equals cosecant theta. The higher level kids need it, but you can see it. You can see it. Sorry, you can see it. Let's try another one. 1 minus cosine theta times 1 plus cosine theta. You might recognize this using the FOIL method at the difference of two perfect squares. You might multiply it out. You get, 1 minus cosine squared theta. From the identity, that's sine squared theta. And that's it. One more. Sine 2 theta. Another identity are your double angle formulas. So, let's see. And then one I'm going to date up is, sine 2 theta times cosecant theta. And what does this end up being? Let's see. So this is 2 sine theta, cosine theta times 1 over sine theta. This goes out with that. Final answer, 2 cosine theta. Let's give you a sheet. There's no IB questions, but we're done with trigonometry. And that's it.